Today you're going to reverse your first program with me. Let's do it. But first, what exactly is reverse engineering? Reverse engineering is how hackers, malware analysts, security researchers figure out how software works without any of the source code. And all you really need is curiosity to get started. That's the cool part. If you haven't been following the daily reading challenge, go ahead and follow me, subscribe. Every day I go ahead and I read for 15 minutes a day and try to just pick up a little bit of things here and there. I do this to actually try to go through all the books I have because I always say I will and then I never do. So I really thought it would be cool for me to do a challenge, show some videos, but also progressively work our way up to actually try to reverse some software. So we've been reading this book called Reverse Engineering, Secrets of Reverse Engineering. At this point, we're at page 295, chapter 8. But we've also been reading for the past 51 days. I've tried many different learning styles as well. Reading, taking notes, drawing diagrams, using the whiteboard, and it really does help. But ultimately, we want to play with all the knowledge we have, which is why we want to do these challenges. That's the best way we're actually going to learn. I love the book, but I can't remember all of the things on it, all the little specifics. Those things just come with practice. So, let's get started. Today we're solving a beginner challenge called CrackMe on this website called crackmes.one. The programs on here are intentionally built so we can reverse engineer them. So we'll be using this website for many other challenges. The challenge I have here in front of me is called CrackMe 0x00, and the mission is to find the password. So let's try to do that. So in order for us to actually try to do this, let's download the actual file. We see the file here, we get a zip folder. Cool. Let's try to open it. Downloads, I think it was this one. So let's do open with, and then we're gonna wanna extract the files from here. I'm gonna put them in documents. We'll put it here. Now it requires a password, but the password is just like the website name, crackmes.one. So let's try crackmes.one. There you go. It extracted the file. Go to your documents, and there's your file. So we have to reverse engineer this file, but let's actually try to run it and see what it does. Now before we continue, I just want to let you know that I'm on a virtual machine. It's connected to the internet and it's connected to my host, but I've also done this challenge before, so I know that it's not malicious. But if you're doing this with any of the other challenges on there, you might want to do it on an isolated virtual machine, not connected to the internet, not connected to your network, because I don't know what's going to be on there and you don't either. So let's be safe. Now let's go to documents and let's see if it's even executable. It looks like it is already. It has the permission to be executed. Let's see what it does. Format error. Let's see what kind of file this is. x64, oh, Mac. So it's for a Mac. Interesting. So I wonder if it'll even run here. But it is x86, 64. It might be able to run. Now it looks like I can't actually run it in Kali Linux. I would have to run it on my Mac. And as I mentioned before, it's pretty safe. I'm going to do that, just that. So let's go ahead and try to run the program on my Mac here. I already have it. It's called CrackMe. Cool. So we see that it's just saying enter the passphrase. Sure, why not? Juan is cool, duh. Try again. All right, so we don't know the passphrase. That's our goal now. We have to figure out the passphrase, come back here, enter it, and see how much money we make. To start digging in to the actual file, let's actually open up Ghidra. And if you don't remember what Ghidra is, it's a disassembler which will allow us to see the assembly code of this binary. So I have it here. Say yes for it to be analyzed. Cool. So now here on the left, we have symbol trees, exports, the functions. The recompiled version of it here on the right at a higher level, what the disassembler thinks it is doing. Let's actually just go through some of these commands. So as we read before in the book, pushing RBP, usually we see EBP as base pointer, but that was 32-bit. This one's 64-bit, it just changes the E into R. Same thing, same concept. So what this is doing is just setting up the new stack pointer as the reference. All right, what else did we learn here? REX, going into here, Let's go all the way down to this one here, printf. Cool, it's calling this function, and then it's calculating the address of this here. Enter the passphrase, cool. Calls print, then it calls scanf, which is actually going to allow you to enter the passphrase, and it'll store that somewhere. So let's see where that gets stored. It looks like it'll get stored in one of these variables here. And then it's going to do a string comparison between most likely the password and the one we're entering. Then down here, it actually does the comparing of this with local 90. Now this is a function call here. Jump if not equal to, jump if not 0. So if it's not 0, it's gonna go all the way down here and it'll call this. If it is 0, it'll go ahead and say, oh, congrats, you found the password and you're good to go. But if it's not 0, that means it failed and it'll go down here. If it didn't fail, it would print and then it would jump here, which is this section down here. So if we got the password correctly, it would go down to this section via a jump. So this is the function move, again, comparing RCX to REX, and then it's doing another jump if not equal to, and then all it's doing is returning, popping the base pointer back to the old one, and then just ending the function here. Cool. So what we've been learning throughout the challenge, we started to apply it a little bit. Cool, so we quickly went through a little bit of what we learned in the daily challenge. We started learning some of the commands, some of the returns, some of the base functions, how they're set up, the comparing, some of what all that means. We're not gonna get all of it, right? So the best thing to do here is take each one, just look it up on Google, look it up on ChatGPT and be like, hey, explain what this opcode does, what this operand does, and go from there. Now let's take a look at what it actually thinks the code will be. Cool, so it actually thinks it's gonna be this code here. We can read most of this. This looks like C code. We see that it has a bunch of variables assigned, some buffers there, a built-in string copy into local 1D with Knox is the best as a string. Interesting, that looks like a hard-coded password to me. But let's read through. Created by Knox, enter the passphrase, scan. Whatever we insert gets inserted into this variable here, which cannot go above 107 characters or else we'll have a buffer overflow. Now it'll compare what we entered with local 1D. And if we go back, it's a character array here. You can see that of size 13. And here we're going to copy Knox's best into it. What is this? I think that's 10, 13. Yeah, it makes sense. So size is 13. We're copying this string into local 1D. And down here, we're going to compare it as if it were actually the password. And if it's true, we crack the password. If it's false, we just try again. So we see that Ghidra actually made some kind of code that it thinks this binary is going to make. And inside of that, we can see the password being hard-coded. Now let's go ahead and actually see what is happening when we just put the password. And let's see if it's even right. Is it really this easy? I mean, it is the first challenge we're ever doing, so probably. All right, let's try to actually run this program. Here I have it. And let's put the password that we found. Knox, I think it was is the best. Enter. We're in. So we found the password. Now it won't ever be this easy. We have to keep learning the assembly code. We have to keep learning the C code and see how they interact, what they do, what functions do, look them up. There's a lot of research. And this was a really easy program, so we had an easy time. As we do more of these, we're going to see that some of the programs have been encrypted, obfuscated, packed, and many other different things. I say we take this first challenge as something to start building our confidence. We'll do the second challenge and we'll keep working our way up. But also don't be afraid to use the internet. Don't be afraid to use some ChatGPT to look up some of these answers, look up some of the opcodes, operands, and what do the jumps do, because it's confusing sometimes. And we need to learn, right? How else are we going to learn? I personally don't know everything on here, but I'll figure it out. I just need a little bit of more time, but It can be figured out with enough time, patience, and practice. So we'll keep reading this book, but we really need to do some more challenges. I'll see you guys later.